They look at the graphs. Okay, so there is this one. So the thing is sketch indicating all interface. One f of x is equal to 2 minus 3 part x minus 4. So that's where the structure from. Yeah. So if you ask to sketch this function, the first thing that we talked about when you're doing these graphs, we said this number here, when you draw the plane, that number 2 is the horizontal ascendant for an exponential function. So then you, after you draw this line, you substitute 0 where there is x. So now we have f of 0, that is 2 minus 3, or 2 times 0 minus 1, which is 2 minus 3 or minus 1. So this is going to be 2 minus 1 over 3, which is, we put over 1 there, we get 3 down, we have 6 minus 1, is like 5 over 3. So 5 over 3 is actually less than 2. So it means that it's crossing here. And because the base is negative, the graph is going to go this way. So it's cutting at 5 over 3. Then it's also cutting in the y. So for the y, you always equate f to 0. Meaning we have 2 minus 3, 2x minus 1 equal to 0. So we push the 3 the other side. Okay. When you do that, we know that the function that drops the powers is a log function. So we have the log 2, because we use ln 2 is equal to ln 3, 2x minus 1. So we drop the power now. So we have ln 2 is equal to 2x minus 1 multiplied by ln 3. Okay. Then now we can divide. So we're going to have ln 2 divided by ln 3 is equal to 2x minus 1. So we push 2x the other side. And then we push minus 1 the other side. So we have ln 2 over ln 3 plus 1 is equal to 2x. Divide by 2, divide by 2. So x is equal to ln 2 over ln 3 plus 1 over 2. So this one is the x intercept. So you can even leave it just like that. Say ln 2 over ln 3 plus 1 over 2. No, this number is wrong. So we did it the wrong way. Because the graph is supposed to go like this. Like this. So this is going to over 3 plus 1 over 2. Yeah, like that. Okay. That's how we put our graph. So this was finding the y-intercept. This was finding the x-intercept. And this circle in here, the horizontal circle. Like that. So this should be one of the easiest graphs. You just struggle to get the intercept, but the sketch itself is an easy thing. If they are simple to you, you just look at the question, you can tell what they're simple to. And then when you substitute 0, you get the one. When you put everything to 0, you get the x intercept. Okay. So we go to question 2. Question 2, f of x is equal to -1 plus log 2 x minus 3. Again, it's about sketching. So sketch the function f of x of that kind. So to sketch this function, the horizontal simple comes from incomplete. So I mean, now it's not the horizontal, it's a vertical. So for log, it's a vertical simple. So we get x minus 3, we get to 0. So saying x should be equal to 3. This 3 is the asymptote. And then, since it's positive outside and inside, it's going to be a curve going inside. Like that. So all we need to know is this one. So we create the whole thing to 0. You cannot say let x be 0 for you to get the y-intercept, because then you're going to have log of negative, which is not defined. So it's blocked by the vertical symbol, it's going to right. And so then, to find the x-intercept, we equate f to 0. So we have -1 plus this log x minus 3. The base is 2, you equate it to 0. So what happens? So you get log x minus 3 to equal to 1. Then you can shift. It becomes x minus 3 is equal to 2 power 1. So that x is equal to 3 plus 2, which is equal to 5. So we have a 5 here. And that's the only thing that we need to find there. Other things we don't care. We have the vertical simple. We also have the intercept dimension. And all that is there. Okay. So you can do this in an easy way. Just get the inside of the log, equal to 0, find the z percentage. From there, where the x tries to substitute 0, if you cannot, then you know that there is no y-intercept. When you put everything to 0 and find the x-intercept, how we move from logs to exponential, you know how we shift. Okay, so we got to the third thing. The third one is f of x is equal to the absolute value of x plus 3 minus 4. So we want to sketch again. So here's the absolute value of x plus 3, then there's a minus 4. So again, just after I see the minus 4, then I have seen the y coordinate of the starting point. Okay, so what is remaining is not the x coordinate. So I equate x plus 3 to 0 and get x is equal to minus 3. So now we are going to have minus 3, comma, minus 4. So this is the starting point. So I equate what is in the absolute, comma, that number is outside. Then the graph starts from here. See that you go up or you go down. But because the absolute is positive, the graph is going up. Okay. So because absolute is positive, the graph is going up. So I need to find the x-intercept. I mean the y-intercept first. By substituting 0, what is x? That would be 0 plus 3 minus 4. So I'll get 3 minus 4. This is 3 minus 4. It is equal to minus 1. So at minus 1, it equals. What's in here? So this should be minus 1. So meaning even this side is going up. So now we need to find this point and this point. Right? So to find those points, we equate f of x to 0. So we'll have x plus 3 minus 4 is equal to 0. That is x plus 3 is equal to 24. That is the absolute. So obviously you get x plus 3 is 4, or x plus 3 is minus 4. So that is x is equal to 4 minus 3, and x is equal to minus 4 minus 3. Meaning x is equal to 1, x is equal to minus 7. So 1 is this side, minus 7 this side. Yeah, this is the easier version of this thing. Let's see another one. We also have f of x is equal to x minus 1 plus x plus 3. So we have now a sum of the two modulus functions that we need to sketch on the same pair. Okay, so the easy way of sketching this is to make it piecewise. The easy way of sketching it is to make it piecewise. Because sometimes, in most cases, they will ask you to redefine and then sketch it. I can also sketch them in pieces and then just combine on the same graph. But they will mostly ask you to say redefine and then sketch. So then what do? We redefine. So to define, we start with, let's start with x minus 1. We define it means we must have it outside the absolute. That is, it will be x minus 1. Of course, if x minus 1 is greater or equal to 0, it is multiplied by a minus if the number x minus 1 is less than 0. Okay? So this means this is going to be x minus 1 if x is greater or equal to 1. It also means this minus x plus 1 if x is less than 1. Like that. So, leave that one there. We come and get x plus 3. X plus 3 will also be x plus 3. If x plus 3 is greater or equal to 0, we also have x plus 3 minus now if this is less than 0. So what does that mean? It means I have x plus 3 if x is greater or equal to minus 3. Then if you multiply by minus x, and if I draw the negative, then that is if x is less than minus 3. So now we have 4 statements. This x is going to vary across those 4. So here's what happens. We know that if something is less than 1, okay? If something is less than 1, there's a possibility that that same thing that's less than 1 could also be less than minus 3. So if I put a table, I'll start with minus 3 with smallest value, and then positive 1. So if I say I want this region to have x less than minus 3, then this one to have minus 3 less or equal to x, which is less than 1. This one to have x greater or equal to 1. When x is greater, you always attach the equal to. That is length from the inequality. And so, if x is less than negative 3, or it's a must. If you find a number less than negative 3, then just know that same number is less than 1, which is true. So when we get this function, which is x plus 3 here, now we want to pick it in the sense of what we have here. So for x less than minus 3, forget this, you get this function. So you get minus x minus 3. Now, when x is greater or equal to minus 3, oh, I've seen numbers. Look, this is minus 3. This is 1. X could be bigger than minus 3 going inside. At the same time, less than 1. So we have numbers here. Okay, so for this function, when x is bigger, we pick this part, x plus 3. But we also know that it's possible that some x can be less than minus 1 and yet bigger than minus 3. So we add the minus x plus 1. Now when x is bigger than 1, up there, we're getting x minus 1 here, bigger than 1. But anything bigger than 1 is automatically bigger than minus 3. So we also get x plus 3. You see? Then now we go to x minus 1. So that's when x is less than minus 1. So we have a minus. So when it's possible that for values, when x is less than minus 1, it includes all the values that are less than minus 3. So for the minus 3 part maintained, we'll get minus x minus 3. And then we also get what? From the x minus 1, we are getting minus x plus 1. And then on the second piece, x less than 1, so the same one, minus x plus 1. And then down here, we want x bigger than minus 3, so we get plus x minus 3. And then the other one, when x is bigger than minus 1, I mean 1, It's also bigger than -3. Like that. Okay. So let's go to the first one. I think the first one, we didn't finish it here. So we're saying when x is -3, it's possible that it's minus that guy. So we put that. Then also the middle part, let's see. When x is less than 1, it should be bigger than -3, yes. Okay, that's okay. So now we're looking for f. So f is the additional term, remember? Oh, it's not very good. I think I was doing everything up there. Oh yeah. So my idea was to separate them and then come back to add them. Now I'll mix stuff. Hello. Hello. So let's do that part. I've mixed up what I'll get to do that. Okay, so I was saying for the x parts, for the -3, we deal with this one alone. When x is less than -3, that function is defined as -x minus 3. When x is bigger than -3, it's defined as x plus 3. When x is bigger than 1, it means x is bigger than -3. So it's x plus 3. So we leave it there. Then we go to x minus 1. When x is less than -3, it's automatically less than 1. So we pick this as negative x plus 1. But when x is less than 1 but bigger than -3, we still pick the same part. When x is bigger than 1, we pick x minus 1. Okay, then now f of x. So it is the sum of those. That's why now we say -x minus 3 plus -x plus 1. Then here, x plus 3 plus -x plus 1. Then here, x plus 3 plus x minus 1. So if we add, we can now write it outside the box as a piecewise. So it is minus 2x minus 3 if x is less than -3. The other one, x minus x, that's 0. 3 plus 1, that's 4. Of course, if -3 is less than or equal to x, it is less than 1. And then 2x plus 2 if x is bigger or equal to 1. So now, so you find that most of them when they say redefine, just redefine, maybe they can give you about 6 now. That's redefine. Then they will say sketch it. So it must be sketched. So here we're doing two things. We're sketching a piecewise function. And then we're also sketching a modulus function in the piecewise. Because we are the modulus that will be, and then you manage to make it a piecewise. So now I want to sketch it. So we'll have -3 here and plus 1. So when x is -3, we are sketching the upper one. So we substitute -3 there first. So we'll have f of -3 in the top function. So we'll get 6 and -2 is equal to 4. So we get a 4 there. Not to do that. Of course, when we come back, we'll include it because of this guy at -3. So include all the way up to 1. Open, but if you can create the entire function. So here we have the line. So we get this line here. Okay, then after x is bigger or equal to 1, you are sketching this guy. So it's going up. And also on the left, you are sketching this guy. So it's going up. So these graphs should be, they should have this kind. Even if it's bent, but it must look like that. For those who want it, then become self-contained. No.
So, just a question now. The previous test we had, was it not? Oh, the previous quiz on the same moduluses, we had a number in front of a modulus. So I was a bit confused how to go about it. Is it to simplify the same one, the
So
number, or
look,
maybe just to go with
if
it?
there is a number, let's say there was a number here, right? If there's a number there, when you redefine, the number is here. So the number goes here. Then you put it here. So after you are done, it will multiply. So you have 2x plus 6. Then you have minus 3x minus 6. Then everything else will be used the same way I've used now. Except it is moving with that now.
Okay, thank you.
So the number does not change the inequality. The number does not change the sign unless it comes with a sign. Otherwise, you just multiply when you're defining, and then that's it. Okay. The next question will be 5. We have 2 minutes before this will start. So we can squeeze in one question 5. So f of x is equal to, remember just being sketches. So f of x is equal to x plus 2 if x is less than minus 1. If x squared if minus 1 is less than equal to x, it is less than 1. And then it's 2. Let's say plus 3x. If x is greater or equal to 1. Like that. Okay, so if they ask you to sketch a piecewise, remember that you are right to be asked to sketch and check if there is a function that is continuous around whatever thing. So today our target is how to sketch. This is how you sketch. It's a piecewise function. So we got minus 1. We also put a 1 here. So minus 1 first, we substitute in the upper function. So minus 1 plus 3, it is equal to 1. So we are at 1 and we open. It's a straight line that is positive. So if we pick a number, say minus 2, we just want to see what happens before minus 1. So they are going to get minus 2 plus 3, which is 0. So the tape will come and catch it. We have a straight line. You see? Then on the other side, if you pick minus 1, substitute in the middle function, you get minus 1 squared, which is equal to 1. So you come and close here. And then if x is 0, of course, you get a 0. If x is 1, you get a 1 squared. So we have something like that. Okay. Then if you again pick the 1, put it in 2 plus 3x, we get 5. So the result is 5. Well, pick some number bigger than 1. So we'll have 2 plus 3 by 2. That's 2 plus 6. Is over there. It's going.
Excuse me, sir.
Hello.
How did you know that on x squared is curving?
Like, a quadratic, I mean, think about it. Have you ever thought of a quadratic like this?
No,
So it's a quadratic.
understand.
Yeah.
Thank you, sir.
If you find the power is bigger than 1, then you know it's not a square line, it's a cube. So that's how you sketch that one. So now you want around it. It's just a step in. The idea is that now people do that. It's actually important to do that. Extremely good. So you need to have this tool, like whatever they ask you to sketch there, it must come out. So you sketch exponential, log, you sketch the modulus, both types. They now sketch the piecewise because the modulus went to piecewise, so that will also sketch it differently. So now you need to sketch the tree. Sketch sign, sketch cos, sketch time, sketch code, sketch set and concept. But those I gave that they are giving you sign and then cosec, some cos and then set. So there I'm fine. I know you don't sketch it. So I think the sketches now have been covered. It was quadratic. I don't think they asked you to sketch the quadratic. Then the other point that we need to sketch is the right this time. You have sketches. You go for the function. It's fine. Well, we have a simple something like that. Good. And then after we have the sketches, so we know that 25% of the text is done because those are sketches. So 25% solve it, equations, and 5% rules where we say like anything with something, this property involves any combination. Then 25% application. Differentiate, find the slope, find that cover everything. Very good. I guess the beginning of the first. Doing the guys. I'm sorry.